just sort of a routing layer and an application services layer that's built on top of 802.15.4. So here's the ZigBee protocol stack broken out a little bit more, and the keys on this slide is that the underlined portions really are showing you the things that ZigBee adds. It supports instead of just a point-to-point or a point-to-multi-point network topology, it supports this cluster tree mesh or this mesh network topology. And I'll show you a diagram in a little bit of what that looks like. It also adds another type of node, whereas before we had that coordinator full function device or the end node reduced function device, we also have this new device class that's known as a router. That device is able to forward packets on behalf of other nodes in the network. It also has this other layer of reliability, which are these application layer acknowledgments. And I'll talk about how those actually work. It's the same deal, though. It's based on 802.15.4, so it has these 16 channels of digital spread spectrum in which it can operate. So there are two types of addressing modes, and actually they follow nearly exactly with the 802.15.4 addressing modes. You've got the same 64-bit IEEE address. This is a 64-bit number that's programmed into every device before it's deployed. It's not settable by users. And then you have this 16-bit network address, which is going to be unique also to every node inside of a PAN. Now, we haven't talked what that term means, PAN, but what it stands for is Personal Area Network. So when you talk about a set of nodes in a wireless device network like this, it's referred to as a PAN. The 16-bit network address is actually used because it's shorter, and it means that we can actually store a lot more routing table entries in our nodes. I'll talk a bit more about that. The one thing is that it's volatile. In ZigBee, that 16-bit address can actually be changed by the network, by the networking stack automatically. So if you're writing an application and you're trying to address something from node A to node B, you very rarely actually want to use that 16-bit address as sort of your primary key to access one of those nodes, since it can change. So here's what a typical sort of ZigBee network looks like. You've got this coordinator in the middle. You've got all of these routers here that are attached to the coordinator, and then you have all of these end devices. And we'll talk exactly what each of these devices mean. But what you can know, what you can glean from this diagram already, is that any end device, such as the one here on the far left, can actually talk easily to the one here on the far right, even if they're out of radio frequency range from one another, because the data can hop along all of these different nodes. In ZigBee, there are a couple of different ways, a multitude of different ways actually, of sending data from one node to another. One of them is broadcast mode. And actually, you never want to use broadcast mode in your application. You might think, well, you know, I'm trying to broadcast to maybe a bunch of different signage or a bunch of different devices, and I want to send them all new instructions at once. And a broadcast might seem like the right way of doing that, since you only need to write out one packet to your network. Actually, broadcasts are used, they're reserved in a way for special activities inside of a ZigBee network, and they're very, very expensive. And we'll talk about why, but you almost never want to use a broadcast. There's unicast mode, where it's just like it sounds. If I want to send a packet from point A to point B, I'm just going to unicast that packet by using its 64-bit address or by using its 16-bit address. Again, I'd like to drive the point that I would recommend doing that with the 64-bit address rather than the 16-bit address, especially if you're using one of our gateway products. So how does a ZigBee network actually start? And this actually follows the same for 802.15.4. They more or less follow the same sort of network formation procedure, more or less. What happens is that a PAN ID, a personal area network ID, must be chosen. Either you let the coordinator choose it or you program one in, like 1, 2, 3, 4. What happens is that coordinator node is going to scan the energy, the actual RF energy across all of the 16 channels that it has in its band. And it's going to try and pick the channel with the lowest amount of energy present on it, the quietest channel. It's going to send out a beacon request to see if that PAN ID has already been established by somebody else. And if it's in the clear, what it's going to do is it's going to choose that channel and PAN ID combination to establish a network. After it does that, it's going to allow these little router nodes to join. And so a router, in an attempt to join a coordinator or other router, will actually sort of do the same thing. It'll scan all the channels that it can, and it will send out these beacon requests looking for a coordinator or a router that's already established on that PAN, and then it will begin the join sequence. There are these end node devices. The end node devices are significant from routers or coordinators in that they are the only low power or sleeping devices that are on a ZigBee network. They're the only things that are actually allowed to fully go to sleep. A coordinator or routers have to be fully powered at all times. So an end node must locate a router or a coordinator in order to be able to join the network. And it's going to do the same thing. It's going to scan all the channels, and it's going to send out a beacon request and go through the same join procedure. But there's one additional piece of significance to an end node. Since end nodes can sleep, it means that they're not always available to be able to receive data from the network. So if I send a packet to a sleeping node, that packet actually has to wait somewhere in the network. And that waiting means that that end node is actually going to consume a resource someplace while it's sleeping, which implies that there is a limited number of end nodes that can actually join any one router. And actually, in our present ZigBee release, our Digi ZigBee firmware, that number is 10. So it's important to know when you're provisioning a network for ZigBee devices that you actually have to have this ratio of routers to end nodes. And right now that means that you have 10 end nodes to every one router. So let's talk a little bit about broadcast transmissions. Why are they special? How do they work? Well, what happens in a broadcast transmission is that data is literally sort of blindly sprayed about the network, and in order to avoid broadcast storms in this transmission mode, what happens is that the broadcast is actually recorded by each of the nodes that listen to it. So if I send out a message, we'll call that message A, and it propagates from the coordinator to the router here, what happens is that message A's signature is going to be recorded in a little table. And that message is actually going to be rebroadcast by each of those nodes in the network 3 times. And after the third time, a node will refuse to rebroadcast that particular message. That is a preventative measure to stop things from rebroadcasting forever and ever. But you can sort of get the feeling that this is an expensive operation if things are just retransmitting the same message over and over and over again without acknowledgement. It's actually